Solving one variable inequalities. So when we solve an equation, we simplify either side of the equation or add, subtract, multiply, divide on both sides. This is your review so far. This matches with what we're doing in solving an inequality, where we simplify either side of the inequality. So combining like terms, distributing. Uh, uh, if there's anything to simplify, we can simplify that. And we can add, subtract, or multiply, divide by a positive on both sides, which is almost the same as this. But what's different is when we multiply or divide by a negative, when we multiply or divide by a negative, it needs to be both of those things, we will switch the inequality sign. Why would we do that? Well, if you take 3, that's going to be greater than 2. If we multiply this inequality by, let's say, 2, what happens is 6 is being compared to 4. Which number is bigger? 6 is bigger than 4. When we have 3 being compared to 2, 3 is greater than 2 again. If we add 1 to both sides, well, we'll get 3 plus 1 is 4, 2 plus 1 is 3, 4 is greater than 3. What changes is when we have 3 is greater than 2, and now we choose to multiply by, say, negative 1. Now we get negative 3 and negative 2. But on our number line, if there's 0, here's negative 1, here's negative 2, here's negative 3, 1, 2, 3, 4. When I say 3 is greater than 2, it's saying that 3 is on the right of 2 on the number line. 3 is greater than 2 because 3 is on the right of 2 on the number line. Same thing when I say 4 is greater than 3. 4 is greater than 3. When I say negative 3 compared to 2, well, here's negative 3, here's negative 2. Which one's further to the right? Well, here 3 was on the right, here 4 was on the right, here negative 2 is on the right. Negative 2 is the bigger number. So, what happened? These stayed the same, these stayed the same, these changed. I have heard the argument that this is kind of stretching the number line. This is shifting the number line. And this is flipping the number line. So, whichever way you prefer of remembering it is fine with me. But you do need to know that whenever you multiply or divide by a negative, we will flip the inequality sign because now the comparison is going to be the opposite. So, if we divide by negative 2 here to solve this inequality, we say f is now greater than positive 8. Here, if I multiply by negative 12, then these will cancel out. They'll multiply to positive 1. And I multiply by negative 12 on the other side to keep the balance. And 1/4 times negative 12 is negative 3. And that flips the inequality sign, giving x is greater than or equal to negative 3. So notice that both of these times the inequality changed because we multiplied or divided by a negative. Here, we subtract 6 from both sides. We get negative a is greater than or equal to 9. Divide by negative 1. Get a, remember that negative a is the same thing as negative 1a. A is less than or equal to negative 9. Here, we're distributing. We distribute a negative 6x minus 12 is being compared to 0. We did multiply by a negative, but going back to the rules, it's only when we multiply or divide by a negative on both sides. Right now, what we just did was we simplified one side of the inequality by distributing. Because we're simplifying one side, we do not flip the inequality, and this is still greater than. That's really important that when you're multiplying by a negative on one side, because you're simplifying, you are not changing this sign of the inequality. Now we can add 12. Negative 6x is greater than 12. Here, we're dividing by a negative 6 on both sides, so then it becomes x is less than negative 2. Inequalities can have the same complexities that solving equations do. So here we have to combine like terms. When we combine like terms here, we get negative 16t minus 18 is greater than negative 6 minus 100t. I'm going to add 100t to both sides. This becomes 84t minus 18 is greater than negative 6. Now adding the 18 to both sides gives 84t is greater than 12. And lastly, we divide by 84. 84, we're dividing on both sides, but by a positive number. So it does not change the sign. It has to be dividing on both sides by a negative. All three have to be true. So this is our answer. Last one, subtract 8 from both sides. That gives us 15, or negative 15 halves. Negative x over 4. If you need to review how to subtract fractions, go ahead and do that. Multiply by negative 4 on both sides. Negative 4 divided by negative 4 is 1. So x is, we multiplied by a negative on both sides. X is greater than now. And this becomes negative 15 times negative 2 is positive 30. So x is greater than 30. Thank you.